Okay, welcome everybody. Welcome to eCHO episode 116, where we're going to be revealing security blind spots with Tetragon. So welcome to this Friday, 24th of November, wherever you are, whether you're on YouTube, watching us on YouTube, LinkedIn, Twitter, wherever you are, and welcome. So I'm going to start, as always, with the news. And I will then bring our guests onto the stage. If you're watching us, please put a comment in, in the comment box. Let us know where you are, how you're doing today, what you've been working on. We will be having a fun demo later on, but again, let us know how it goes. And so, to begin with, what have we got here? We've got it's been quite a quiet week. I think we just the fallout of KubeCon for many of us who has a chance to be there, and also it's Thanksgiving in the US, so it's traditionally the quieter week, and many of my teammates have been off this week. But what we've got a couple of new things that have been published. I wrote up a blog post with Duffy, which where we cover our experience at KubeCon in Chicago. I know this was a topic of last week's show, but again, we've got a bit more insights and photos and background on into everything that went down back in the US. So have a read and let us know how it goes. Hello, Nuno. Nice to have you on. It's nice to see you. Always a regular on this program. We also published a BGP design guide. It's by Raymond, who's our field CTO in EMEA at ISOVenant. And it's I've published a lot of kind of BGP little videos and more content, and we've got some labs, but it's the first time I've seen a really comprehensive comprehensive guide on why you would run Cilium on BGP and what's the point of all these different features. Raymond covers BGP and LBI PAM, graceful restart, and even SRv6. So lots of different features which I know are being used. I think BGP is one of our most popular features on Cilium. So again, have a read at the blog post. And the third one I just wanted to highlight is one that teammate Dean wrote down, which is a tutorial around deploying Red Hat OpenShift with Cilium. And I see a lot of questions on the Cilium Slack about how you can use both of them. So again, Dean joined us from VMware about 6 months ago, and he brought a lot of OpenShift experience. And this guide is just a really good, easy to follow tutorial on how to install Cilium on OpenShift and how to verify how it works. Again, take a look and let us know. Hopefully it will help us if you ever have a requirement to use Cilium on OpenShift. And hello, Tony. Nice to see you as always. Hope you're doing well. Cool. Couple of things and we've got reInvent, and I know Liz mentioned, but I will repeat this today. Liz is going to be at reInvent, which is in Vegas, and you can get some time with Liz, or you can go and watch some of the demo she will be doing there next week. And finally, the CFP for KubeCon Paris is closing on Sunday evening or Monday, so very, very soon. I have submitted 2 sessions. I have no idea if any of them will be accepted. I appreciate the competition is really fierce to get a session accepted at KubeCon, so we'll see. I had a go at it with a couple of a session that I hope to co-present with a couple of friends. And I also wanted to highlight that the CFP for Cilium and eBPF Day is also going to close. I think that's a week later, maybe 1st or 2nd of December. Again, if you feel passionate about Cilium, whether it's a particular design or story, I really enjoy Cilium Con in Chicago. I thought there was some fantastic use cases of Cilium. So just don't hesitate and submit. And if you want to have a chat about it, just let us know and hopefully help you put together a really strong application. So that's the upcoming events. And what we will now move on to is today's topic. So let me bring Piotr. So first, how are you doing?
Yes, hello everyone. My name is Piotr. I'm fine. Thank you for invitation.
Okay, excellent. So I actually on LinkedIn, when I promoted this event, I said you and I sat next to each other in Palo Alto in the Bay Area almost 8 years ago now, and we both joined VMware back in end of 2015, early 2016, and we did our new hire training. And wow, 7 years on, and we're teammates again. So I guess
we are moving closer to application and even getting deeper into the virtualization stack, because we moved from the user space to the kernel space.
That's right. So I guess that's what kind of brought you to the world of Cilium. So what do you do now? Just tell us all.
Yeah, a couple of interesting things. I'm a senior solutions architect at Isovalent, supporting customers and advising them in terms of eBPF-based solutions produced by Isovalent. And among other duties, we are supporting customers if they have some issues. Of course, every software can have some interoperability things, but yeah, that's interesting stuff. And prior to that, I spent some time at Palo Alto Networks, Cisco, VMware, and other different companies. So my background is, roughly speaking, networking and security. So cloudy stuff.
Yeah. Awesome. And so you actually suggested this session, and I'm going to interrogate you as you do your demo, and I will answer questions. Some of them will be dumb questions, some of them will be like genuine questions that I don't know the answers to.
Me neither. I'm just presenting. Yeah, but let's try to answer any questions. So please ask anything you want, put on the chat. We are absolutely here to discover for you anything you can learn about Tetragon or eBPF runtime-based security.
Yes, so that's the topic of today. It's Tetragon, and you sent this shared this on LinkedIn, which is a picture of the architecture, and maybe let's have a.
Yeah, this architecture is, simply speaking, our environment we will move around. So first of all, there is a bit of story behind the whole chain of attacks. So I classified this chain of attacks based on my 3 attack framework. So phase 0, until phase 4. And there are different stages of these attacks. Red color are adversaries, so either people or persons who are trying to get into the environment. There is also malicious pod on the left-hand side, which is getting the code through the supply chain attack. So the code is already there and is trying to discover what is going on, which ports are available, which ports or applications are vulnerable. And then there is an attack on yellow pods. Yellow pods are either vulnerable or misconfigured because there is a over-privileged container or the pod, or there is a role-based access control over-permissive, which makes some possibilities to laterally move across pods. And there is a reverse shell, so 2 arrows upwards to the red pod symbolizes reverse shell, which allows to access from external entity. It doesn't have to be external entity, it can be internal one as well. So in the next step, we will do privilege escalation, command and control access, and we will end up in a situation where when we take over the control of the whole node as well as the Linux, and we will be able to instantiate whatever we want. And Tetragon here is to see all these events happening. Why? So the question is why like that? Do we need Tetragon? And this is my intention of this session, because based on the previous experience and tools, I can say that I'm quite impressive of capabilities of Tetragon, because always some tools were something missing. Either reverse shell was not completely fully visible, or process in memory process execution was not visible, or kill syscall was invisible. So always there were some missing ingredients to the overall observability.
And you've got log4j here. So it's a whole demo we're going to show today based on the log4j breach.
Yeah, log4j, and on the right-hand side, there is a remote code execution. So you can set up reverse shell or gain the access and control through the various techniques. Log4j, Log4j is old technique, but it's so, again, giving so much possibilities. You can send the whole file through the Log4j. So I'm not saying that Log4j is a threat now, but such kind of layer 7 attacks or threats are the most critical things in our environment, because if we use managed Kubernetes clusters, they are very well protected. 2 years ago, I tried to compromise GCP, and I could run kubectl from the host on GCP. Today, I cannot, because the agent, the segmentation of privileges is so strict. The tokens are one-time only tokens. They are strictly received and sent. You cannot do so many things like in unmanaged Kubernetes cluster, but still there are some possibilities, and these possibilities are in layer 7, when you can gain the control of the pod and steal the data simply. Even if you cannot compromise fully the cluster, you can still steal the data. And Tetragon with eBPF code within the kernel can help to, first of all, be aware of such kind of threats, and then do some enforcement as well.
Awesome. So we will, and actually we've mentioned Tetragon, and I think I'm hoping many of the people here are familiar with Tetragon, but that's the tool we're going to be using today. Tetragon went 1.0 just about 3-4 weeks ago now. Again, the the blog post is going to be in the show notes if you want to read a bit more about it. But yeah, we're seeing still a lot of excitement and more use cases around Tetragon. So I will stop sharing and I will let you share, but I will keep asking a few questions. Right. And yeah, thanks, Karim. We will make sure that we zoom in on the terminal and
All right. Do you see my screen?
Here we go.
All right. Let's just briefly touch Tetragon. This is the two main layers. One layer is in user space is Tetragon agent, who is pushing the code written in C, which is attached to the hook points in the kernel to observe, to monitor, but as well as to enforce some behaviors in the kernel. As you know, any traffic which is going through or between pods is using the kernel still. So anything related to the pods, containers, but also the host itself is actually visible in the kernel. And with eBPF solution, it doesn't have to be the Tetragon, of course, but if you use eBPF-based solution, you can have not only efficiency of this monitoring, but also you have the very broad range of actual monitoring attributes. So you can monitor files, processes, syscalls, memory, data, networking events, including layer 7, including DNS lookups, including TLS versions. And I encourage you to attend Tetragon deep dive session with our CTO and product manager, Natalia and Thomas Graf, around the deep dive into Tetragon architecture and solution. More things are, you can hear about it on 7th of December. You can register to the session. Go ahead, let's go ahead to the demo. So we will initialize, start the attack from adversaries. So from the right-hand side, we have the attacker who is seeing such a website. This website is vulnerable to the remote execution code, and we will exploit it through the specific chain.
Right. So you've got you got a Karen cluster, right? I just saw.
Yeah. So just to introduce, I have a kind cluster on Instruct platform, and this kind cluster is very simple. One is one node to keep resources tidy and economic. But what is important, this is without any additional Cilium tool. Tetragon is standalone, no Cilium, no other tools, no any other components which is not non-standard. This is standard kind cluster with but default networking settings, core DNS, etcd, and other stuff. QProx, exactly, anything you want. By the way, if we, at the end of the session, I can reveal some stuff about eBPF as well. But yeah, in this case, we have QProxy, all the stuff. And we just push the eBPF code. So this code is monitoring, first of all, but also can enforce some behavior. So if we have a look into the logs already have some indication what is happening in the system. You may ask, what is the overhead? Overhead is around 2% per 1.5 million of events. This is the level of scalability of Tetragon. we will observe all the events in the text form. So in this tab, we will enable compact version of events. Compact, which means very short, to the point log, and we can have, of course, more attribute-rich JSON format and logs, where we will be equipped with additional attributes and data.
Okay. But so just to stop you, so this command will run will go into the Tetragon agent, and there is some kind of CLI, right? It's called the Tetra CLI that you can run on the agent. Is that right?
Absolutely right. So this is the way how you can get to the Tetragon container within Tetragon daemon set, and through the external CLI Tetra, which is called Tetra, you can analyze or display all the events in a compact version for the namespace default. You can use different switchers, and you can say that you are focusing on the specific ports or IP headers or ports. So you can narrow down the search scope of logs.
Awesome.
Yeah.
You're running it in the background, and then we'll do some activity, and we should start seeing some events being displayed. Is that right?
Absolutely, absolutely. On the other tab, there is an external host, which is listening on the port 8080. So external host is expecting reverse shell coming. So okay. Nothing here yet. The attacker will be used later. Vulnerable application is for later. This application is hosted on pod called API. So this is the pod with the code, which is not malicious, but is wrongly written, which is susceptible to the specific kind of attack, which is remote code execution. And to launch the remote code execution, we will use this tab in this edit pane. We will paste the command which is specifically crafted. So to see this command, I wrote some couple of hints here. This will be the first chain used. What we have here, we have essentially do the remote code execution, which is the command after the semicolon. So you can put, let's say, normally you can use this service to encoding your text to specific base 64 form. But if you type text semicolon and ls will be executed internally on the application. So if I do right now echo this base 64 message, and I will try to decode it with base 64 decode, I have a listing of internal folder where the code was executed.
Oh, interesting.
So in the same way, I will do the reverse shell initialization to set up the call and the tunnel to the external host. So I'm indicating that I'm using NC. Of course, if there's no NC netcat, you need to find a different way, and I will show you in a second a different way without installation of netcat. There is an IP address of the external host, which is 10.244.09, port 8080, and shell. Spaces are filled with %20, which is the code for space. And if I push this through the application, let's see what happens. There is a connection coming, but the connection was dropped immediately. Why? This is on purpose because I set up already a tracing policy which is observing connections on each of the pod and is killing the connection to the specific IP address. Let's first of all have a look on the logs given to us by Tetragon. So we can notice all the processes launched and executed in each pod on each node, which is monitored by Tetragon. We can notice echo text, ls, which was executed previously, first of all, and then we can notice NCAT, IP address, and port 8080 with the shell. Then there is the exit and information that we killed this process and this tunnel effectively. So the tunnel was established for a second and killed just right after this occurrence. So in that way,
yeah, sorry to interrupt, but I think there's a good question here, and I think you kind of answered it, but Karim is asking, are all these events synced, i.e. it doesn't matter on which container pod you end up in?
Yes, it doesn't matter. It's supported on the host level, on the container level, or the pod level.
Good stuff. And it kind of shows us like a kind of a cluster-wide kind of essentially visibility, right?
Yes, that's the cluster-wide. Of course, each node requires own agent, which is taking control of the local policies and eBPF code, which is pushed to the kernel. But nevertheless, observability can be combined, which means you doesn't have to hop by hop observe and jump over all the nodes in the cluster. You can get all these logs in a centralized manner to the Splunk or Grafana or other tools which are collecting logs and produces significant, metrics. And you can have a look into the logs to have a look into logs more thoroughly into extended JSON format as well. And this is nice because you can get more information about what is exactly this process all about. So if we have a look, let's say we will do kubectl get pods -a. First of all, kubectl logs. We will take the logs from Tetragon plus we will use grep and 244.09. We will focus on specific IP address.
Can you just maybe zoom as well a little bit?
Yeah, I can do this. Hold on.
That's a bit better. Thank you.
Okay, now should be better. And JQ for better formatting.
You just need the logs at the start. So.
Yeah. So all the events. And what is nice with Tetragon, you have more information, more data which can be correlated. So not only that the one process NCAT has been killed with the syscall, but actual binary which was executed, the arguments which were used, other child or parent information. So you can have a full process ancestry tree. Why is it important? Because processes can be muted or cloned, or can be created branches of the processes, and to track them all, you need to have such capability. Of course, I'm not saying that there are no such tools on the market. There are, but something which is happening in the kernel, and you would like to, for example, correlate binary and PID with the malicious activity on the networking level, it's not so common. Why? Because let's imagine the best next generation firewall on the market is sitting at defense at the entrance of the environment. Is it aware of PID or what is the process which is generating the traffic? Not really. And if the process is swapped by the malicious process, how can we discover that? We need to have a deep insight to the elementary processes which are happening in the kernel.
Yeah, and I think that's probably, for me, that's some things that get me the most excited maybe about Tetragon is, you showing the event, you were showing the binaries, the processes, the kind of more container Linux based, but then process based, and then you show the context of Kubernetes, the namespace, the pod, and shows all these two things together, right?
Absolutely.
So,
and this is
there was a question from Ali. Hi, Ali. Nice to see you. And Ali's asking if we could see the policy definition. And I will also say hello to Min. Thank you for joining us.
Yeah, so that's exactly on our screen right now. This is the policy which was responsible for the skill. And it may look somewhat complicated, but it's fairly easy. I mean, you have a specific method used, kprobe, which is using the way how you hook the code in the kernel. You can use kprobes, uprobes, tracing points. So these are places which can give you specific dynamics or static points where you can attach your code. And the code can be executed based or triggered based on the specific arguments. If those arguments are happening, then the code is executed, the eBPF code.
Okay, so tracing policy. So in a way, I related to Cilium, where you have your network policy, where you specify, the traffic you want to allow. Here you specify what you want to observe and what you want to do with it. Is that, how would you describe it?
Yes, in one policy you can instruct that you want to just observe, but you can also set up the policy to react. So this is the spec for observation, and this is the rest of the spec for reaction. So this is a bit misleading. It maybe shouldn't be much, maybe should be set action or do action, but essentially this is the action, reaction on the observations. So if I remove this portion, then this is just observability. What this observability is saying that I'm interested into the connections where destination address is exactly this IP address. So you can easily set up, I used mask /32, but I can use any mask, and I can describe what is the scope of my environment where the connections can be established. But what is nice, I can correlate this information with binaries. So I can say that specific application can establish connections to the external world or other IP addresses, but some of them not, which is giving you higher flexibility in terms of who can connect what. In standard firewall, firewall can detect on layer 7 based on signatures or behavior what is the application, but it cannot detect what is the binary, if the binary has been swapped by malicious code. Here you can at least observe it, but also react. There are different reactions, and in the documentation, if you enter the page tetragon.io, this is only thing you need to remember, you can find all the operators, reactions, arguments you can use. By the way, this documentation is pretty good and can give you the recipes how to create your own policy, including the GitHub repository where you can find examples of such policies. So that's the first steps where you can.
And I think if you go back on the Tetragon docs for me, please. And I think it might be on the left-hand side. You've got network monitoring, maybe. There are a few. Oh no, this library. Sorry, just the policy library here. Yes, that's something I found super interesting because if you're not, let's say, like an expert in Linux and knowing about K-props and that kind of stuff, and you just want, okay, I want to visualize all the incoming SSH connections, or I want to look out for all the outbound connections, so everything that, let's say, on my cluster, I want to see all the traffic coming out of my cluster, if just for monitoring purposes. You can use this set of predefined policies, right?
Absolutely. And the flexibility of such policies is quite, I mean, it's not huge, but it's significant, which means you can set up and utilize different arguments, different fields from observations about processes, about binaries. So you have plethora of attributes, and you can create a combination of those attributes in one policy.
Cool. Do you want to carry on with a demo?
Yes. So I will just do the shortcut and do the following way. So tracing policies. I will remove this is exactly the same policy which killed the connection. I will remove that one and I will continue. So I will repeat the attack, but from a different angle, from the angle of log4j. So that attack was blocked, then this attack will be successful. Or not successful, we will see. Maybe it will be blocked as well. So this other attack, the monitoring is turned on continuously. This attack will be carried out from a different port. Listening on the port 88 is turned on again. Attacker port is Ubuntu port, and we will do attack from here, but using a different code. We will use this crafted message. And just briefly, because this is not the demonstration how to do attacks, but we can spend other episode about it, of course. But through log4j, you can send files. You can send full files, and one of the files is encoded with base 64. And this base 64 contains the other method of establishing reverse shell. So there is no endcat inside. This is just bash, pure bash. But because of complexity and special characters, I encoded it with base 64, and I'm sending this with as encoded in an encoded form. But I'm encoding again because I'm sending this to the file which is created locally on the victim spot. Plus, I'm executing additional commands to transform this base 64 to the script and assign the execution privileges and execute the script. So the script is all these commands are hidden in the payload. So the victim is not aware that this vulnerable pod is not even aware of this attack because it's receiving these commands in the payload, is sending to the Java LDAP server and is receiving back the commands for execution. So vulnerable application is here, and let's jump to the vulnerable application. This is the current status of the folder, and let's trigger the attack. Not this one. This one. And if it's successful, then reverse shell should be established automatically. Yeah, we have bash. And if I now do the uname -a, we can see that I'm sitting on the vulnerable application pod. Vulnerable application pod have additional SH files because they were uploaded through layer 7. And one of these SH2 is having exact code of the executed command to establish reverse shell. And now important information. Many solutions on the market are blind to such kind of attack, using not netcat, but using bash script, bash command. And what we can see in Tetragon, we can see everything. I mean, starting from kernel message, of course, we don't have on-the-fly decoding using base 64. That's doable as well, but nevertheless, we have information where we are connecting, where we are establishing connection, what is happening there. This is also happening or visible on the external pod because this is monitored by the Tetragon again. But even if we don't monitor external entity, of course, we don't have the control over the whole world yet. Yeah. But we still see the source information. Okay, so connectivity, kernel message, and then establishment of TCP connection for the reverse shell and other stuff. Uname A, which I executed, listing stuff, cat to show the file.
I think it's pretty cool, but I imagine these logs get really verbose, right? If you have a cluster with a real, how could you use your CLI to reduce the amount of, to focus on the specific?
Yeah, the alert fatigue is a common problem nowadays. So you should first of all use good tools which can collect many data. All data, I don't think, maybe not all data are needed, but first of all, you should create policy which is focused on your application, on the most vulnerable aspects, which are layer 7, which are how the processes are working. Then you can use graphical representation of what is happening in this environment. So even though you have a lot of data, you can represent them in a digestible manner. You can produce alerts for the most significant events. So for example, you don't need to know for every step which is happening here, unless there is a connection outside, for example, established to, or a try of establishment of such a connection to domain name, to the FQDN dynamically generated, which is not our. Yeah, that's the suspicious activity, isn't it? So so to avoid alert fatigue, there are some specific techniques you need to use, but definitely that's the problem. That's true. And with cooperation with Grafana, with our products as well and solutions, you You don't need to rely on or sit only in the text version.
Okay, cool. I think that we're getting some great questions, and I want to make sure we cover some of them. So thanks, Karim, for the great questions. Does Tetragon have the capability of understanding the behavior of each pod container and automatically build a policy for it?
Not yet, but that's on the roadmap. So building semi-automatically or automatically policies based on the observed events or behaviors or any attacks or some flows is something which can be built using scripts. And actually, I did such things already for different solutions in the past. This is actually a common requirement. When I supported NSX, that requirement was also there, and even now, creating from the sophisticated log, creating a policy is not an easy stuff. Why? Because you don't. First of all, you don't know whether the traffic is producing the legitimate pattern or not. So first of all, you need to have analyzers which can tell you whether there is an included attack inside the traffic or observed behavior or not. Okay, let's assume we are doing tests in an isolated lab, and we can separate those elements, those behaviors. Then you need to create a template and make a decision to apply it. That's possible, but there are not so many tools, or there are some basic tools on the market. We are going into that direction. If you are interested into that using Tetragon, that's possible with scripts at this moment, but we are going ahead to have it more automated.
Yeah, I think it's a great point. And Carrie is making the point that are there any logging monitor modes to help customers come up with the policies, and also can we capture new events? And I like this kind of idea of you look at your cluster, at your pods, and you see you have this kind of golden pattern. This pod is behaving well. And if it started to behaving in a different way, let me know, and maybe even create a policy based upon it. And it's a bit like with Cilium, where you can essentially, with some tooling, you can generate a network policy based on the flow that you observe. And that's similar kind of approach.
Yeah, that's true.
Cool. So you had more to show us.
Yeah, going ahead, at this moment we are we break into API pod and vulnerable pod, and either from one of these we can go ahead and we can break into pod Ubuntu using kubectl exec. Why is it possible? Because of misconfiguration with role-based access controls. And of course, that's the huge mistake, but nevertheless, it may occur that production environment is well secured, but lateral movement from layer 7 or from the pod to the development pod or development environment is not so well separated. Or on layer 7, it's possible to move across these environments using the same technique. Because if the production is vulnerable, the development pod will be also vulnerable to the same code or to the same exploitation. So we will go to the next stage, and we would like to would like to execute kubectl to move to the other pod, but there is no kubectl locally, so we can either fetch the kubectl from the public repository, or we can disclose it or set up a web server, either again on the external node. I did it on a different host here. Essentially, we can fetch the kubectl from such a server. So if I right now use this external server and fetch the kubectl, I make kubectl executable. I can run kubectl get pod because of misconfiguration in the RBAC rules. And also because of RBAC rules, I will be able to do kubectl and exec -ti Ubuntu pod 4. Why like that? Because the current pod where I'm at this moment is not overprivileged. It's not in the privileged mode, so I cannot get the access to the underlying host. It's not having the mounted additional resources from the host. So my attack can be very successful at this moment as well. I mean, I can steal data, I can try to sniff or do man-in-the-middle attack. But nevertheless, if I want to go to the host level, I would like to gain additional privileges. That's not the full command. So apart from indicating Ubuntu 4, I need to run specific command. Okay, where I'm at, uname -a. Yeah, I'm on the Ubuntu pod 4 right now. So my malicious code is one level down on this yellow pod, Ubuntu-pod 4. One level less and one level more, and I will be on the node level through ns-enter command. So the next step is to use ns-enter. Before that, let's see what is possible to observe in Tetragon. We have another level of visibility. Of course, the same level of visibility, but with for the next phase of the attack. So we can see get pods. Yeah. So kubectl commands are visible. If there is a question about admission controller, we don't have admission controller yet, but that's also the plan to have integration with through the API and to do some admission controlling or to do audit of the logs. At this moment, we are doing low-level visibility and enforcement is also possible. So we can block actually such kind of execution of kubectl on the pod or the host. And we can see the connection established because we are going further down. Please look, I'm still using the external host. So that's the kind of inception. I'm receiving reverse shell, then through reverse shell, I'm going through to the first pod, then to the second pod. And now let's go down to the pod level, to the host level with the ns-enter. Ns-enter is a command to gain the access with the namespace with the PID1, which is the host level. And let's see if we get it. Yeah, that's the Linux kind control plane. And if we have a look on the Tetragon, yeah, that's the also confirmation. And again, this can be blocked. I will be not blocking at this moment because I would need to repeat many things, but observability is the first step of good security. You cannot block or track the events if you are not aware. So that's that's obvious.
Good stuff. So if you look back at your picture, we started almost at the top now, and then we went down from.
We went down. We are at the node level at this moment.
Nice. Okay, and you took advantage of. Again, it's a demo, so there are some vulnerabilities that are maybe obvious, but I think what we can like the RBAC misconfiguration, right? But that's showing that all the stuff that you can see, and then once you can see things, then you can do something about it.
Yeah, the thing why I'm showing that is because I experienced with some tools on previous tools that sending the command execution or doing some activities through the reverse shell is not necessarily obviously visible to every tool. So what especially impressed me with Tetragon and eBPF based solution is that actually I can see all of the things I'm doing. Maybe there is something which cannot be observed yet by Tetragon. Of course, I didn't try all the kind of attacks, but this basic level I'm perceiving like log4j reverse shell, sending executed commands through reverse shell, doing nsenter, doing some low-level stuff. All this stuff are visible.
Cool. I know Ali was asking as well, any plans to simplify usability with a UI?
Yeah, UI is already in place. So what does it mean? It means that you can utilize, for example, Timescape or Hubble UI. Yeah, if you use Hubble and Hubble UI, you can already.
But that's just in the Enterprise Edition, right?
Yeah, that's Enterprise Edition. But in the OSS, you can use Grafana, for example. You can use tools which are collecting data and make some drawings. Yes, so that's also possible. It depends on the tool set.
Amazing.
Right. Okay, the last step, once we are on the host level, we can actually compromise the host and the Kubernetes cluster. Of course, the full compromisation is when we can not only destroy, but also try to sneak into the data, or pretend to be someone else, because then you can get even more sensitive data. And to achieve that, you can get, for example, these techniques are the common one and standard one to for example, get all the tokens which are stored currently on the host level. You can get that. You can, for example, get information.
And what are these tokens used for?
These tokens are used for the authentication with the API server. So if I take one of these tokens, let's say from the Kube API, this is the token. I'm on the Ubuntu pod 4 level, which is privileged pod at this moment. And if I do, for example, let's do export token. And now I will see what kind of kubectl not found. Let's check.
Let's
grab kubectl. Oh. And now let's repeat. Token flag list unknown flag. Okay, I know what. Okay, so using this token, I'm pretending to be the API server pod in this case because I grabbed the token from API server, and this is the list of privileges I can do with this token until it's expired. But if it's expired on the host level, I can grab the token or pretend to be kubelet, because kubelet is constantly connecting. Okay, kubelet is having different privileges, permissions, but still API server pod is refreshing its token. So I can take the token again and use it for a specific set of instructions. So I can interact with Kubernetes cluster, even though I don't have the direct login and password, but I can use tokens.
Nice.
And on the host level, I can then do whatever I want with containers, which means, okay, let's do the ns enter again, because I'm on the different level. Now I'm on the host level back again. And on the host level, I can see all the containers, including not only Kubernetes one, but also standalone or separated containers. Of course, if there's a host which belongs to the Kubernetes cluster, these containers will be strictly related to Kubernetes. And that's another thing which is Tetragon can give us the hand, because some of the solutions on the market are either focused on the host level enforcement and visibility. Some of them are focused on the container or Kubernetes level. But what if the attacker gained the access to the host and instantiate the standalone container? And this container will be not visible in the list of containers which we have here. So then, if the security tool is also not aware of this container can do a lot of malicious stuff without being disrupted, without any disruption. So that can bring a lot of damage. And the last stuff which we can, let's say, do, and we can do a lot of stuff, but the last thing I would like to show is instantiation of the container. So I can use an image. If I cannot fetch the image from the external repository, I can use one of the images which are already cached on the host. So that's this image is not found, but yeah, I can do images list. I can use one of these images, actually Cilium images on the host. So yeah, I can instantiate the Cilium if I want. If I use namespace kubernetes.io and then images ls, then I have images used by Kubernetes cluster. So I can grab one of them, for example, image for kube scheduler or kube proxy, and I can try to instantiate my own container.
Okay. And again, that would be out of sight of Kubernetes, like, and whatever tools.
Yeah, out of the sight of Kubernetes, but also it might be out of the sight of security tools which are just focused on Kubernetes. If the security tool is focused on not only on Kubernetes, but on anything which is happening on the node, which is possible if you have kernel level visibility, then you are protected, because regardless whether you are running the process directly in the memory, or in the Docker container, or in the container D, or in the host, or in the Kubernetes pod, whatever you do or whatever the attacker do, everything will be visible. So also here you can see CTR command, and this is still visible.
Very cool.
Yeah, so that concludes the activities I would like to share with you, and to summarize.
Awesome.
Yeah.
Yeah, no, great stuff. Yeah, go recap for us.
Just one statement. I put some list of visibility capabilities of Tetragon. It may be, of course, it's not depleting all the possibilities, because, as I mentioned, there is no yet automation in terms of policy recommendation, or there is no interoperability or connection with API of Kubernetes. But this is something along the way. But even though without these integrations, still with just OSS tool, you can get this list of capabilities. Okay, without the second line. Sorry, it's a different release of Tetragon. But other capabilities are for you, including changes in the Linux capabilities, privileges, permissions. We can detect such changes. I didn't present, also because for the sake of time, syscalls detection, so we can observe different syscalls, monitor, react. So yeah, having such broad scope in the OSS tool, that's for me, it's amazing stuff.
Yeah, amazing. I don't know if there's any other questions by anyone who's been watching. Been fantastic. I've actually learned a great deal of things. Thanks for sharing this, and thanks Ali for the feedbacks. Thank Tony for the feedback. That was fun. Thank you for joining. We're running a bit late because we were enjoying ourselves, looking at all the stuff that Tetragon can show us. But I did like how you showed us all the many ways you can kind of move laterally, right, within your cluster, and that, you know, hopefully with Tetragon you can see a lot of that behavior throughout throughout the attack. So thank you everybody for joining, and we hope to see you in the next episode, and take care.
Thank you for your questions. Thank you for hosting me, Nico, and for the discussions, and yeah, all the best. Have a good weekend.
Take care. Bye-bye.
Take care. Bye-bye.